A book to accompany Scientific Eye has been published by Bell and Hyman and is available priced £5.50 from your local suppliers or from Books for Students at Bird Road, Heathcote, Warwick, CV34 6TB.
The steamship Titanic was launched in May 1911. On the 10th of April 1912, she sailed from Southampton on her maiden voyage, bound for America with 2,200 people on board. She was 270 meters long and built entirely of steel, the biggest steel ship ever built. Some people were amazed that a steel ship would float at all. How do you think 45,000 tons of steel can float? She was the grandest passenger liner the world had ever seen, and Captain Edward Smith was proud of his ship. They also thought the Titanic was the safest ship ever built. They called her the Unsinkable. 3 days later was Sunday. She was halfway across the Atlantic. In the evening, the passengers were wining and dining. On the 4 passenger decks, there was every sort of luxury, from a swimming pool to a Turkish bath. Steaming along at 22 knots, they saw ahead what looked like just a little lump of ice. The time was 11:45. It felt like just a little bump, not even enough to spill the drinks on board. The passengers weren't worried. They didn't realize that the ship had been holed below the waterline. Icebergs are much more dangerous than they look. Let's see the collision again. All you can see is the tip of the iceberg. 9/10 of it is hidden underwater, and there are often jagged bits sticking out below the surface. So when the Titanic hit the iceberg, the collision was underwater. Captain Smith ordered the passengers into the lifeboats, but there weren't enough lifeboats for everyone on board. At 2:20 a.m., the Titanic went down. The unthinkable had happened. The unsinkable had sunk. "700 people were rescued, but 1,500 were drowned." Why do icebergs float mostly underwater? How do ships made from steel manage to float at all? And why did the Titanic sink when the water ran in? Some objects sink in water, but others float. What decides whether something sinks or floats? Tomatoes sink to the bottom, but bananas float up to the surface. Can you explain why? And if you push down something that floats, like a football, what happens when you let go? What pushes it up again? Hippos are massive animals. So are manatees, or sea cows. Even the calf is much bigger than a person. Nearly a ton, a good mass for a manatee. But in the water, all its weight seems to disappear. It floats about like an astronaut. What's lifting it up? The word hippopotamus means river horse. Why is it so light on its feet? And what about you? Why do you float like an iceberg with your head sticking out of the water? Where's your weight gone? If you were lowered slowly into a pool, what would happen to your weight? These scientists are studying the weights of objects hanging in water. When a brick is lowered into water, its mass stays the same, but its weight gets much less. So what's pushing it up? A tin of beans weighs 2.5 newtons in air, but much less in water. There's an upthrust of more than 2 newtons. With an apple, the effect is even more dramatic. Its weight drops right down to 0. Any object will float in water if the upthrust is as big as its weight. How about you? If you were lowered into water, how much upthrust could you expect? If you went all the way down, would the upthrust equal your weight? Lowering things into water solved a royal problem for a Greek scientist called Archimedes. The king had given the crown maker a block of pure gold for a new crown. But when it came back, the king was suspicious. Had the crown maker pinched some of the gold and mixed in some cheaper metal? Archimedes weighed the crown. The mass was right. What about the volume? Cheaper metals are lighter than gold for their size, so if it wasn't pure gold, the volume would be greater. Before he could face the king in the morning, Archimedes wanted a bath. He was still worrying about the volume of the crown as he lowered himself into the warm water. And then he had a brilliant idea.
Eureka!
When he'd lowered his body into the bath, it had pushed some water out. If he lowered the crown into a bucket, it must displace its own volume of water. The volume was too big. There was some cheap metal in it. The king was not pleased. What the crown maker hadn't realized was that a given mass of gold has a particular volume. You can't escape it. The king got his gold back, and Archimedes lived happily ever after, thanks to his idea of displacement. You can use displacement to measure the volume of an awkward-shaped object like your hand. As long as the inner container is full to start with, the volume of your hand must be exactly equal to the volume of water displaced. Could you do that with a whole person? What precautions would you have to take to make sure it's a fair test? And And how would you measure the volume of water? When you know the volume and the mass of something, you can work out its density. The density of any material is the mass of 1 cubic centimetre. So the density of plasticine is 3.0 grams per cubic centimetre. Different materials have different densities. Most metals are dense, and brass has a density of 8.4 grams per cubic centimetre. The density of water is 1 gram per cubic centimetre, and anything denser will sink. How can you predict what will float? Wood has a low density, so you'd expect wooden boats to float. But what about big steel ships? Why doesn't the steel sink? Do you think the shape of the object matters? Can you make a boat out of plasticine? Plasticine has a density of 3 grams per cubic centimetre. So you'd expect lumps to sink in water, but if it's the right shape, it floats. That's because it displaces more water. Take a wide boat with a loose bottom and push it down, and it displaces a lot of water. Why doesn't the bottom fall off? It still doesn't fall off with a heavy weight on because there's a lot of upthrust. As long as enough water is displaced, there's enough upthrust to carry tons of coal. But what happens if the boat fills up with water? What happens to the upthrust? So now, can you see what happened to the Titanic? They thought she was unsinkable because she had steel bulkheads dividing her into separate compartments. If one compartment filled with water, it wouldn't matter. But the iceberg probably ripped a hole in 4 of them. Some solids are denser than others. What about liquids? Different liquids also have different densities. That means that a liquid with a low density will float on top of a liquid with a higher density. One liquid that is less dense than water is alcohol. What if you drop things in? Remember, in water, bananas float, but tomatoes sink. What will happen in a liquid that gets denser as you go down? Why do you think the 2-bit banana float at different levels? Why do you think they float in layers? Submarines need to be able to float and sink. To do that, they behave like whales. Before they dive, whales blow. They have to breathe out to get rid of the air and increase their density. So do submarines. Inside, submarines have big tanks they can fill with air or water. Fill them with water and the submarine sinks. Can you work out why? And how do you think it comes up again? Divers also need to change their density. There's a lot of air trapped in the suits. Why do you think they need heavy belts? One thing that has a much lower density than water is air. Bubbles of air rush upwards. How could you use the low density of air to raise this valuable old wreck? So if you were a salvage expert and you found an aircraft at the bottom of a lake, how many ways could you think of to raise it to the surface? What difference does being underwater make to the weight? And if you'd found the steamship Titanic at the bottom of the Atlantic Ocean, how would you go about trying to lift her? And what other problems might there be?